Hi, in this video we're going to test the observed proportion P of a binomial distribution and introduce the kind of idea of a hypothesis test. It says the probability of passing a certain test is 9 out of 20. A teacher employs new teaching methods and claims that there is an improvement in the pass rate. In her class of 16, there were 11 students who passed the test. Perform a suitable hypothesis test to decide whether her claim is true. Right, there are going to be several steps here, and these are going to be highlighted in green and underlined. So it says, first state suitable null and alternate hypotheses. H0, which we call the null hypothesis, is that the probability of success is 9 out of 20 given in the question, and in words we could write there is a 45% chance of passing the test. H1, which we call the alternate hypothesis, that's going to be P is greater than 9 out of 20. The teacher claims that her teaching methods represent an improvement in the chance of passing the test. Now, because we're looking for a definite improvement, we do what's known as a one-tailed test. So the alternate hypothesis determines the type of test we do, one-tailed or two-tailed. One-tailed will be if there's a definite increase or decrease, and two-tailed if we're looking to see that P is not equal to 9 out of 20. So we're going to perform a one-tailed test. One-tailed test. Okay, the next step we've got to do is write down the distribution of the random variable that represents the number of students who would pass the test if H0 is true, if the null hypothesis is true. So the null hypothesis is that the probability of success is 9 out of 20. In her class there are 16. So therefore under H0 we need to test that X belonging to a binomial distribution, 16 in total, and the probability of success is 9 out of 20. The third step is to calculate the test statistic, i.e. the probability that X is greater than or equal to 11 under H0. So, probability that X is greater than 11 is equal to 1 minus the probability that X is less than or equal to 10. Now, we don't actually have tables for 16, 9 over 20, but we had 9 over 20 is 0.45, so we can get the tables. If we go to the probability calculator in GeoGebra, which I've shown you already to do, you open up a page of GeoGebra and under View, select Probability Calculator, change this to binomial. You need to raise this up a bit, set this n to 16 and p to be 0.45. We want greater than 0.0486. Now, if you were using tables to do this, then you need to use this. Okay, and we'll have to do 1 minus 10, so we'll have to look at this one. So we're going to use these commutative tables here, which are generated by GeoGebra. So, using the CDF table, so n is 16, p is equal to 0.45. You won't find those in a book, so we generated them using GeoGebra. We want 1 minus probability x is less than or equal to 10, so it's going to be 1 minus 0.9514, which gives me 0.0486. So we tested the test statistic, and now we need to state the conclusion. So to get to the conclusion, it wouldn't always draw a graph, but we're going to use this graph here, again generated by GeoGebra. So we've got x is binomial 16, 9 20ths. We want greater than 11, so we're going to do 11, 12, 13, 14, 15 and 16. Now 5% will be here in the 10th one, because if I just show you, if I go back to this and change this here to 10, we get 0.12, that's 12.41%. So the critical value, or the critical region, will start in somewhere in the 10th value. And over here, if our value, when we calculate it, if our proportion is over here, then we reject H0 in favour of H1. This is 5%. So we want it to go over 5%. Here it's 4.86, and here it is 12%. So we are going to say, in this idea, we're going to reject H0. This is known as the critical region. And we know this shaded region here to be 0.0486 or 4.86%. So therefore, what we say is, if as 0.0485 is less than 0.05, now these are known as p-values, or 4.86% is less than 5%, we reject H0 because this bit lies in the critical region, and say there is significant evidence that the new teaching methods improved the chances of passing the test. Now normally we test at 5% unless otherwise stated in the question. So perhaps we could add to that at the 5% level. Okay, so this has been a video to show you how to do a hypothesis test for an observed proportion P of a binomial distribution. I hope you've understood, and I thank you very much for watching.